Hi, welcome back my YouTube channel, Yuki English. In this channel, let's practice listening English using technical YouTube videos. Today, I'm gonna use how the garbage collector works in Java, Python, and Go. I'm embarrassed because I'm a software engineer and I experienced 6+ years, but I'm not sure about garbage collector. So today I'm looking forward to learning this topic. Okay, let's dive right in. This video have 5 minutes. So today I'd like to learning only one 30 minutes or 2 minutes back. It's enough for me. So over 30 minutes, it is too long for me. So stopwatch. Start to timer, 30 minutes, start. Okay, today, uh, I'd like to try understanding the concept and each sentence meaning.
Garbage collection makes programming in modern languages a lot easier. At its core,
Wait, wait. Sound. Uh, okay. So I wear off my AirPods.
is about reclaiming memory that's no longer in use by a program. But why
Mm,
does it matter? Without effective memory management, programs can gradually eat up more
memory
and more
management.
memory, leading to slower performance, crashes, and outright failure. Today, we're diving into what garbage collection is and how it works in popular languages. At its heart,
Correction.
garbage collection revolves around a simple question: which objects in memory do the program still use? This question is answered through the concept of reachability. Every program has GC roots. These are starting points like global variables and stack references. Any object that can be reached by following references from these roots is considered alive and must be kept. Everything else is garbage,
Reachability, GC roots, accessible, garbage.
ready to be collected. To efficiently manage memory, garbage collector typically implement a generation of
How to manage the memory. This is the essential concept for thinking garbage collection.
hierarchy. This design is based on an empirical
Like a minesweeper.
observation. Most objects die young. In Java Virtual Machine, memory is divided into three main areas.
Java garbage machine has a major three area: young generation, old generation, metaspace.
The young generation, old generation, and metaspace. New objects start life in the young generation's Eden space. If they
Eden
survive
space.
multiple collection cycles, they graduate to the survivor space within the young
Survival space.
generation. The rare objects that persist even longer earn promotion to the old generation, where collection happens less frequently, but more thoroughly. The metaspace is Java-specific, used for class metadata to help reduce memory footprint in large applications. Other languages might implement generational collection differently. For instance, V8 uses a two-generation system, and .NET's garbage collector typically uses three generations, numbers 0, 1, and 2. The most fundamental garbage collector strategy is the mark and sweep algorithm.
Mark and sweep algorithm.
It works in two phases. First, during the mark phase, it traverses all references starting from the GC roots, marking each reachable object.
Like a DFS.
Then, in the sweep phase, it reclaims memory from any unmarked objects. While effective, this basic approach requires the application to completely pause during collection, known as a stop-the-world pause.
Stop the world pause. Application thread, stop the world pause.
Which can freeze the applications for noticeable periods of time. These pauses become more problematic as heap sizes grow and applications demand better responsiveness.
Maybe here is half, but today is the first lesson, so let's watch until the end.
An enhanced version called the tricolor mark and sweep algorithm reduces these pauses by categorizing objects into three sets. White objects are considered potential garbage. Gray objects are known to be reachable but haven't been fully explored. Black objects are both reachable and fully processed. By maintaining these three distinct sets, the garbage collector can pause briefly to do initial marking, then continue examining gray objects and their references while the application runs. This incremental approach avoids the long pause required by traditional mark and sweep, where the entire object graph must be traced at once. Languages take different approaches to garbage collection. Java, for instance, offers several GC algorithms: serial, parallel, CMS, and G1. The evolution of these algorithms reflects the need to balance performance, latency, and scalability across different application types. They're designed to handle everything from small-scale apps to massive enterprise systems, often using a generational model to optimize performance.
Heap.
Python uses a combination of reference counting and a cyclic garbage collector. The reference counting handles most cases by automatically deallocating objects when their reference count drops to 0. The cyclic collector cleans up circular references, which reference counting alone can manage.
It's very confused. Complicated.
Go uses a concurrent mark and sweep collector, which operates alongside the application to minimize pause times. It leverages a tricolor marking algorithm mentioned before to handle reachability efficiently. This allows garbage collection to proceed incrementally without significantly disrupting application performance. As helpful as garbage collection is, it's not without drawbacks. For one, there's the performance overhead. GC cycles can introduce unpredictable pauses, which might not matter for some applications, but could be a problem for latency-sensitive systems. There's also memory fragmentation. Some collectors leave gaps in memory, making allocation slower over time. Memory management also involves balancing used pool and free pools to ensure efficient allocation and deallocation without fragmentation. With garbage collection, we usually lose fine-grained control over when cleanup happens. This can lead to unpredictable pauses in your application. If you like our video, you might like our system design newsletter.
It's very difficult. Even though in Japanese, this topic is difficult. So, of course, in English, very complicated. Okay, so step by step, breakdown. Today's part is the first part, only 1 minute and 40 seconds. First sentence.
Garbage collection makes programming in modern languages a lot easier.
Garbage collection makes programming in modern languages a lot easier. Garbage collection makes our modern programming very easier. So garbage collection is very useful and helpful for us, for our engineer. Next.
At its core, it's about reclaiming memory that's no longer in use by a program.
At At its core, it's about reclaiming memory that's no longer in use by a program. Mm, this sentence is mm, reclaiming reclaiming memory that's no longer in use by a program. So reclaiming memory is no longer in use, no longer in use. So reclaiming, we no longer we no longer use reclaiming memory in the program. Okay, later look up reclaiming memory. Reclaiming memory. I'm not sure this. I'm not familiar. This is unfamiliar words. Next.
But why does it matter?
But why
With
does it matter? But why does it matter?
the effective memory management, programs
Without
used by a program. But why
program.
does it matter?
What does it
With
mean?
the effective
Without
memory
effective
management,
memory management. Without effective memory management,
programs can
it
gradually eat
can
up more and
gradually
more memory.
eat up more and more memory. Eat up more and more memory. I can understand. That makes sense. Eat up more and more memory. In Japanese, same expression. 日本語でもメモリを食うって表現をするように、英語でも can gradually eat up more and more memory。メモリを食べるっていう表現するんだね。次。
leading to slower performance, crashes, and outright failure.
Leading to slower performance, crashes, and outright failure. Leading to slower performance, yeah. Crashes, yeah. And outright failure. Outright. I don't know these words. Outright failure, but maybe this is negative meaning because slower performance and crashes and failure. So this is maybe negative meaning.
Today, we're diving
Today,
into
we're
what garbage
diving into the
collection is
garbage
and how it
collections
works in
and how
popular
it works in
languages.
popular languages. Yeah. Mm.
At its heart,
At its
garbage
heart,
collection revolves
garbage
around a
collection
simple
revolves
question, which
about at its heart, at its heart, at its heart. But this is, this mean maybe its core concept. At its heart is the most important thing. So at its heart, garbage collection revolves around a simple question. Revolves. I know involve, but revolve. Garbage collection revolves around a simple question. Maybe this means revolves around a simple question. Garbage collection. Mm, Garbage collection has a simple question. Okay, I'm not sure. Next.
which objects in
Which
memory do
object
the
in
program still
memory
use?
does which objects in memory do the program still use? Which object in memory do the program still use? Mm, the subject is the program still use do and which object in memory? Ah, which object in memory do the program still use? I got it.
This question is answered
Question
through the
answers
concept of
the concept of
reachability.
reachability. This question is answered through the concept of reachability. Reachability. This is a new concept. Reachability. Reachability. Hmm. What is the concept of reachability?
Every program has GC
Everything has
roots.
GC
These are
roots. GC roots. I'm not sure GC roots, but next sentence maybe explain for me.
starting points like
Yeah.
global
These are starting points,
variables
like
and stack references.
global variables, and stack differences. Hmm? These are these are starting points, like global variables and stack reference. Ah, global variables. I know global variables and stack reference. Mm, mm. ZC root is a start point. What? What's what's start point? I'm not sure. Hmm. Starting points.
Any object that can be
Point
reached
of
by
view
following
can be
references
reached
from
by
these
following
roots is considered
references
alive and must be
is
kept.
considered right.
Everything else
Must be kept. Any object that can be reached, any object that can be reached by following references from these roots is considered alive and must be kept. Hmm. Okay, breakdown. This sentence is very long and complicated and unfamiliar grammar, so it is difficult to understand for me. I couldn't. So please help me, ChatGPT. Hey, ChatGPT, please tell me this sentence meaning. And any object that can be reached by following references from these routes is considered alive and must be kept.
Sure, this sentence is about how a garbage collector in programming determines which objects to keep in memory.
That's right.
Essentially, it means that any object that can be accessed directly or indirectly from certain starting points, called roots, like global variables or active function calls, is considered still in use and won't be removed. In other words, if there's a way to get to an object from these roots by following references, it's considered alive and won't be cleaned up.
Mm, mm. Uh, let's break down. Uh, this subject of this sentence is any object and decorate it. That can be reached by following references from these roots. This is decorates any object. And verb is considered. Any object is considered alive and must be kept. So we have to keep this object. This object. What object? Mm, it can be reached by following references from these roots. But I'm not sure about it can be reached by following references from these roots. What's mean?
Of course, it can be reached by following references from these roots means that you can start from certain well-known points, the roots, and trace a path through references like pointers or links to get to that object. The roots are usually things like global variables, active function calls, or anything that the program can directly access. If you can follow these references from the roots all the way to an object, then that object is still considered alive or in use and won't be removed by the garbage collector. Essentially, it's about whether there's still a way for the program to reach and use that object.
うーん。40% understand, but only 40%. Uh, please tell me the reference. What is reference? Following reference.
When we talk about references in this context, we mean links or pointers that connect one object to another. In programming, objects often reference each other, like a list containing several elements, or an object having fields that point to other objects. Following references means tracing these connections from one object to the next. So if you can start from a root and follow these references through a chain of objects, you can determine which objects are still accessible and need to be kept alive.
Oh, so could you tell me the could you tell me very simple so could you tell me the simple sentence instead of this sentence? Any object that can be reached by following references from these routes is considered alive and must be kept. Please tell me more simply sentence.
Sure, here's a simpler version. Any object that you can get to from the starting points is still in use and won't be removed.
Any object that you can get to from the starting point. Get to from the starting point is still in use and won't be removed. Um,
Exactly, that's the idea. It's all about identifying which objects are still accessible from those starting points so they aren't deleted.
mm, reached by following reference. 認証される What mean these roots? So, earlier sentence is every programming has GC roots. These are starting points like global variables and stack references. Any object that can be reached by following references from these roots is considered alive and must be kept. More simply,
Sure, here it is in simpler terms. Every program has starting points called roots, like global variables and stack references. Any object you can reach from these starting points is considered still in use and won't be removed.
mm, that makes sense. Okay, next. Everything else is
This is garbage, ready to
everything else is garbage. Everything else is garbage.
be collected.
Ready to be collected. Ready to be collected.
Efficiently managed memory,
Efficiently managed
garbage collector
memory, garbage
typically implement a
collectors
generational
typically
hierarchy.
generate generational hierarchy. Hierarchy. Everything else is garbage. Ready to collect it. Ready to be collected. Everything else. So this means any object that can be reached by following references from these routes. This is considered alive and must be kept. So everything else. So, うん。Not any object. Not this object is everything else. Is garbage. Ready to be collected to efficiently manage memory. To efficiently manage memory, garbage collectors typically implement the generational hierarchy. Garbage collectors typically implement the generational hierarchy. Uh, Generational is like 60 years old, 50 years old is older, 30 years old and 40 years is middle, 20 years and 10 years is younger. This is general hierarchy. I, mm,
This design is based on an
that is
empirical
based on
observation. Most
empirical observation. Empirical. Hmm, unfamiliar. There are a lot of unfamiliar word. Generational hierarchy and based on an empirical observation. Next,
objects
lots
die
of
young.
die young.
In Java Virtual
In
Machine,
Java virtual
memory is divided
machine,
into
memory is
three main
divided
areas:
into three main areas.
the young
Young
generation,
generation,
old
old
generation, and
generation,
metaspace.
metaspace.
New objects start
Metaspace
life
is
in the
the
young
young
generation's
generation,
Eden space.
Eden space. Eden space. Hmm.
If they survive multiple collection cycles,
If they survive multiple collection cycles,
they graduate to the
they
survivor space
graduate
within
to
the young
survival.
generation.
They graduate to survivor space within the young generation. What mean? If they survive, if they survive multiple collection cycles, they graduate to the survivor space within the young generation.
The rare
The
objects that
rare
persist
object
even longer earn
persists even longer
promotion to the old
after
generation,
promotion to the
where
old generation. The rare objects that persist even longer, even longer, even longer, and promotion to the old generation.
collection
Where
happens less
collection happens
frequently,
less
but more
frequently,
thoroughly.
but more thoroughly. Mm, this sentence is very difficult. Hey, ChatGPT, please tell me this sentence. If they survive multiple correction cycles, they graduate to the survivor space within the young generation. The rare objects that persist even longer earn promotion to the old generation, where correction happens less frequently but more thoroughly.
Certainly, this sentence is describing how a generational garbage collector works. Here's a simpler version. If objects survive several rounds of garbage collection, they move to a more stable area called the survivor space in the young generation. If they last even longer, they get promoted to the old generation, where collection happens less often but more thoroughly.
Mm. Mm. In this sentence, in this word, the subject is object. Is it right? And next question is they are like a human, so if they live longer, uh, their generation become older. So uh, yeah, since if they are if they from the beginning the object lives in younger generation space, but if they live longer and become older generation, so they go into older generation space. Is it correct?
Yes, that's correct. The subject in that sentence is indeed objects, and your analogy is right on point. Objects start in the younger generation space. If they survive multiple rounds of garbage collection, they get promoted to the older generation space. So just like something that lives longer moves into an older group, objects that last longer get moved into the older generation space.
Mm, okay. Object is like a human in this topic, garbage collection. Next.
The metaspace is Java specific, used
Uh, the meta space is Java specific.
for class metadata
For
to
class
help reduce
metadata
memory
to help
footprint
reduce
in
memory
large
footprint in
applications.
large applications. The meta space is Java specific, used for class metadata to help reduce memory footprint in large applications. Um, mm, could you tell me this sentence? The namespace is Java specific, used for class metadata to help reduce memory footprint in large applications.
Sure, this sentence means that the metaspace is a special area designed to store certain metadata. By doing this, it helps reduce the amount of memory that large applications need, making them run more efficiently.
Method space is Java specific, used for class metadata. Java has a class metadata, so Java specific metadata space. Uh, okay. Okay, time up, but I'm not sure about some words and some phrase. So let's look up these words. Please tell me reclaiming memory. So for example, at its core, it's about reclaiming memory that's no longer in use by a program. What mean reclaiming?
Reclaiming memory means taking back memory that a program no longer needs so it can be used for something else. In other words, it's about freeing up space in the memory that was being used by objects or data that are no longer needed so that the program or other processes can use that space again.
Hmm. So reclaiming memory that's no longer in use by a program.
Exactly. Reclaiming memory means freeing up memory that the program no longer uses so it can be used for other purposes.
Okay, next words. What's mean outright? So for example, uh, okay, without effective memory management, programs can gradually eat up more and more memory, leading to slower performance, crashes, and outright failure. What's mean outright?
Outright means complete or total. In this context, outright failure means a complete and total failure of the program, where it stops working entirely.
Complete or total? So, very big failure, very completely failure. Okay, next. Mm, what mean revolves? So, for example, garbage collection revolves around a simple question. What mean?
Revolves around means that something is centered on or focused on a particular idea or question. So in this context, garbage collection revolves around a simple question means that garbage collection is fundamentally focused on answering a simple question.
Fundamentally focused on answering simple questions. Very, really focused. Really focused. Focused focused on a particular idea. Hmm.
Exactly. Revolves around implies that something is mainly concerned with or centered on a particular idea or question.
Hmm. Okay. Uh, so I'm not sure about reachability. So this question is answered through the concept of reachability.
Reachability refers to whether an object can still be accessed or reached by the program. In other words, if there's still a way for the program to get to that object, like through a variable or reference, it's considered reachable. If it's not reachable, it means the program has no way to access it anymore, so it can be reclaimed.
So, mm, so if it is not reachable, the program or the variables and the function is no longer in use by a program. Is it correct?
Yes, that's correct. If an object is not reachable, it means there's no longer any way for the program to access it. Thus, it's no longer in use and can be reclaimed by the garbage collector.
Mm. And mm. What mean empirical observation? So to efficiently manage memory, garbage collectors typically implement a generational hierarchy. This design is based on an empirical observation. What mean empirical observation?
Empirical observation means something that is learned or concluded based on actual experience, experimentation, or observation rather than theory. In this context, it means that the design of the generational hierarchy in garbage collectors is based on real-world data and observations of how programs typically behave.
Empirical observation means uh, experience and experimentation or observation rather than theory. Rather than theory.
Exactly. In this case, observation refers to what has been seen or measured in practice rather than what has been predicted by theory. So, empirical observation is all about conclusions drawn from real-world experience and data.
Hmm. Okay, today's mm, today's learning is end up. So see you next day. Bye bye.